because really the biggest problem is corrosion. So both inside and outside. Because inside you get, the water gets warm and cold, so you get moisture and condensation and everything. So they paint the inside and the outside with special paints.
Well, what do they look like on the inside?
What do water towers look like on the inside?
Yeah.
They're just big vats from what I understand.
Yeah.
And the metal is just like a shell that covers it, or is it?
Yeah, I think.
Or is the vat attached to that metal shell?
I think so.
That's it. It's what you see on the outside is pretty much what you see.
Okay.
Yep, there's not a whole lot of extra structure there.
Okay.
So yeah, water towers, believe it or not, are not that hard to maintain. It's just painting and coating.
Okay.
What are some of the problems that you face related to hard water? Well, do you guys know what causes hard water?
Minerals, right?
Minerals.
Right. So, like where we are, we don't really have hard water problems because almost all of our water comes from the Missouri or the Mississippi or some other surface water. Like almost 100% of our water is coming from surface water. So you don't have minerals aren't really in surface water. I mean, there's some, but there's not anything like what you have in groundwater. So we really don't have a bunch of problems with hard water. But like, let's say you go to somewhere where they don't have, like let's say you go to Kansas, well not Kansas, let's say you go to Indiana, like the middle of Indiana, where they're going to go to groundwater because they don't have big freshwater sources like rivers and streams. They'll just soften the water at the plant. So like, have you guys ever seen a home water softener? So they have like a home water softener. It looks like a water heater, and you put usually it's some sort of salt, it's some sort of chemical, and it softens the water.
So that chemical pulls the minerals out, and then you have some kind of precipitate.
Yeah, you have to clean it out every once in a while.
My aunt has something like that in her house.
Where does she live?
Like 5 minutes away.
All right, so she must have some groundwater.
Well, like if somebody's on a well, which I mean there are people in St. Louis County that are still on wells, but like the water that you get from Missouri American is not hard at all. It's pretty softened.
That's the water company.
Okay, so what are some problems with lead poisoning? Okay, so what community have you guys heard about that has had lead issues? Do you remember?
Flint, Michigan.
Flint, Michigan, right. Okay, so the issue with Flint was, so Flint used to get their water, they used to buy their water from Detroit, and Detroit would pipe the water to Flint. Flint said, hey, we're paying Detroit a lot of money. We don't want to pay Detroit a lot of money. We want to pull water from the Flint River. So they said, because they're going to save money, so they pulled water from the Flint River and started using that. So the water in the Flint River wasn't necessarily the problem. The problem was the water in the Flint River was slightly more corrosive, and the plant did not add the chemical that reduces the level of corrosivity of the water. So what was happening is they were piping the water to people, and where the lead was coming from was the pipes inside their house. So a lot of older houses have lead pipe, and the lead is not necessarily coming from the water. It's coming from the pipes that are leaching into the water. And what was happening is this water was stripping off the lead from the inside of the pipes. That was what was causing the problem. So it wasn't actually the water itself. It was the water stripping the lead off the pipes.
So then if you immediately start adding the anti-corrosive agent to the water at the plant, how come that doesn't immediately solve the problem?
Because it's already started stripping it off. So what ends up happening is on the lead pipes, like so your lead service into your house, it's a small pipe, right? It's like a 1 inch or a 3/4 inch. And what happens is a scum layer, like a layer of stuff builds up around the lead. And what it was is it was stripping that off, and then the lead was just leaching off.
Okay.
So it's not like an instantaneous, you flip the switch and everything is fine.
So you have to send something through that will coat all those pipes again.
Yeah, it stripped all the scum layer off, basically.
A scum layer, that's a technical term?
Actually, I mean, that's kind of what you call it, but I don't know what the technical term is for the layer that builds up on the inside of water. Everybody calls it a scum layer.
Okay.
That's kind of what it is.
But it could be minerals and.
It's a mineral deposit that you get that just builds up.
But it's not like a slime because there's no oxygen in there.
No, it's usually like something that's fairly hard.
All right.
Yeah. Okay, so is erosion a problem? Oh, let's see.
Oh, do you know how they eventually solved that problem in Flint? Because
They
they say
haven't.
that the water is
They haven't whole.
better now.
So they're just adding the right chemical,
Uh-huh.
and that's what they're doing. But I mean, you have to earn the trust of the people. So what they did is they gave everybody lead filters. So there's a special filter that you can pour water through that will take the lead out.
Right.
They gave everybody those. They gave everybody bottled water, but everybody's just freaked out because they don't trust the state anymore, for good reason.
Yeah.
Okay, so how do you protect your pipes from things like natural disasters? That's a good question. Like you guys heard, hurricane down in Houston, down in Texas.
Mm-hmm.
So I was listening to the news on the way over, and they're actually telling people, hey, you have to boil your water because it's really hard to protect underground pipes. If it floods, it's really hard to protect. You can't protect the sewers at all because the sewers are open to air, right? Because you have a manhole that water can get into. The water mains, you don't have as many direct conduits, but what happens is the plants will get inundated with flooding, and they can't be 100% certain that every joint is tight and that you're not getting infiltration. So it's actually really hard to protect water infrastructure from big natural disasters like flooding. Tornadoes can do a ton of damage. Like they'll knock over a water hydrant, right? And then water will spray out, and then you get problems there because you get contamination that way. Earthquakes will totally destroy underground infrastructure because the pipes will do this. So my company will actually probably send 500 people down to Texas this week. So yeah, we'll mobilize like everybody that's available. We'll mobilize them, and they'll go out there and they'll be inspecting all the infrastructure, like looking at all the manholes, looking at water mains, looking at fire hydrants, trying to categorize and see what's.
So if you know that there's contamination between point A and point B,
Yep.
how do you localize that? Like
They-
let's say we have like a pipe from Hannah Road to my house.
Yeah.
And we know that here at my house the water is contaminated, and we know at Hannah Road it's fine. So how do you find where the problem is between those two spots?
Okay, so if it's water main, right? Because that's what you're thinking. Like if it's water main, if the water main is all pressurized, right? So
It'd be very
if
wet
one
somewhere.
spot is contaminated, the whole everything is the water itself is all going to be contaminated. Now if you have a problem, they isolate the problem because they have valves all over the place.
Okay.
So there's valves like everywhere, and they would just go and start shutting off valves until they isolate the problem, and they fix that problem.
And then they get the backhoe out.
Yep, and they dig it up and they fix it or they line it. There's different things that they can do.
Line it.
Line it like with a liner.
Yeah. So
Yep.
oh, you mean rather than just replace the pipe, they.
Yeah, depending
Oh.
on what's going on, they basically it's like a sock.
Mhm.
They push a sock through the pipe,
Oh.
and then you heat it up, and it cures.
Okay. So, and they can do that without having to dig everything up.
Yeah,
Oh.
depends on what the problem is. Depends on what the type of line it is.
Yeah. That's interesting. Did you get that, Paul?
Okay, let's see. Is erosion a
Christian, you're
problem?
paying 100% attention, right? What
Is-
are you looking at?
Is erosion a problem?
I can't see that.
The doc, he's looking at that.
He's looking at the dock.
Is erosion a problem? Yes. Really what happens with erosion now is as rainfall gets more intense, which is what's happening, right? Climate's changing, rainfall's getting more and more intense, erosion becomes more of a problem because channels and streams are not meant for it. So if you guys remember, like in the last 2 years around New Year's Eve, we've had flooding for 2 years in a row. It makes a big mess because the channels just can't handle the amount of water. So, okay, what technology is on the edge of innovation? Probably the biggest thing right now in water and wastewater treatment is water reuse. And I think one of you guys said, other than drinking your own pee. So But that's the next step. That's where we're going. And it's not a big deal. Like, it's not really pushed in Missouri because we don't have the same problems that, say, California does. Our problem is not lack of water. Our problem is too much water. But for most other places in the world, the lack of available water is a big deal. So that's really going to be the next step. And what happens is, okay, so think about, where does your wastewater go? Like, after it goes to the plant, it gets dumped where, usually? Where do you think it gets dumped?
In the river.
Yeah, it gets dumped in the river. So if you think about this, right, who's downstream? Like, the next big town downstream of St. Louis is, say, like Cape Girardeau. Where do you think they get their drinking water from?
Us?
Well, where do they pull their drinking water from?
The river.
From the river. Where does the waste from St. Louis go?
The river.
Into the river.
Yeah. So what happens is, though all the waste from St. Louis, the water that's already been treated, goes into the river. And then a few miles downstream, somebody else is pulling that water out. There's not a huge difference in just going right from the treatment plant right to the drinking water treatment and then sending it out. It's just an extra step, and there's extra treatment that has to be done in order to make sure that the water is 100% safe.
So right from you're saying that it's not too much of a step to go from the sewage treatment plant and just pump that directly into the water treatment plant and
Yes.
put it right back into the pipes.
Yes.
Okay.
That's what's going. That really is the next big step in water and wastewater treatment.
So, like, going for a closed cycle kind of thing more than
Yes.
rather than an open cycle.
Yep, that's exactly what it is. And right now, the reason why, like, nobody worries about like the wastewater right now going into the river is because you're going into the Mississippi. You're going into this massive water body, right? And an old saying that they always heard was, the solution to pollution is dilution. That's exactly what happens. You put a drop of water into, a little cup, or a drop of food coloring into a little cup, right? It turns it red. You drop a drop of food coloring into the Mississippi,
Nothing.
you don't notice it. So that's why they don't worry as much about putting the wastewater into the Mississippi, but going right from the treatment plant to the drinking water plant, there is a little bit more concern, because you do have to clean the water a little bit more. But that's what's happening, because it's just lack of water. So they don't want to pull the water from places like California, where they're getting it from the Colorado River and and piping it miles and miles and miles. They just want to recirculate it all.
For in the end, it's cost, right? You're saving money by having a closed system. But once you get all the technology and
It's a mix of cost and availability. Like, because what's happening is, they're pulling water from the Colorado River. And so you do lose some of that water. If you send it to the river and then pull it back, you're losing water.
water and planes with it and stuff. And
So, let's see. What is water used for other than things like factories and personal use? Man, water is used for everything, like literally everything. So, if you thought, what would you guys say, like, what do you think is the biggest use of water total? What would you guess?
Drinking?
Shipping? Irrigation?
Irrigation's close.
Oh,
That's a second. What do you think is first?
Shipping.
If you use the entire ocean to ship it and you're over the water.
Well, I'm talking about water that gets pulled out of a water body or the ground.
Water that we bother to treat.
Yeah.
Maybe for like watering plants?
Yeah, irrigation.
That's irrigation. Irrigation's number 2.
So what's number 1?
What do you think would be number 1?
Drinking?
Nope. It uses way more water than anything
Industrial?
else.
Turf grass.
It's way more.
Yeah.
Industrial?
Dude, I don't know.
Nope.
Toilets.
Hydroelectric.
Hydroelectric.
Oh my god,
it's
power!
really like
Oh, that
dam
makes
stuff.
sense.
Yep.
Sense.
And they don't really treat that water, but they are pulling that water out.
Oh, okay.
So I mean, someone's, they're pulling the water into something.
Okay.
But in terms, I mean, that is like the biggest.
But you're talking about like a dam, where you dam up a river and you store all that water back behind it in order to create the pressure you need
to run turbines and stuff like that. But like actually touching the water, that's probably the biggest thing.
Okay.
And you'd have to treat that because it heats the water up. So you can't just discharge it right to you just can't discharge it right to a water body. So, but that's the biggest. Irrigation is the next, and then really probably drinking water is the third. But water is used for everything. I mean, literally everything that you do needs water. So, let's see. What treatment do you use? Okay, so that's kind of a broad question. There are a ton of different ways of treating water and wastewater. There's just a ton. I mean, there's all kinds of different technologies that are used depending on the volume of water and the type of waste that it is. Like different things need different treatment. So later I can kind of walk you guys through like water and wastewater treatment in general.
What would you say is the most popular used one?
Well, for water treatment, it's or for wastewater treatment, it's they basically use clarifiers, which are big round tanks.
That's what we saw.
It's aerobic. Basically, you're using bacteria, right, that eat other bacteria. That's kind of like the biggest general broad way of doing it. On water treatment's a little bit less complicated because they're doing things like what you're trying to do with water treatment is make the water a lot of times look better. So they do a lot of polishing and clarifying and cleaning, and they settle out all the dirt. They'll have a lot of settling ponds and stuff like that, and then they just disinfect it. And they add a bunch of chlorine usually. That's like the biggest way of treating water.
And then they pull that chlorine out again before it comes to us?
No, actually, when they send it in, when they send it out the pipes,
dilution.
No, it degrades.
Okay.
So the way that they do it is it comes out with like, at 5, and by the time that it hits the house, it's 2.
Okay.
Which is what it's supposed to be.
Don't drink it too fast.
So yeah, no, they have that all figured out.
Okay.
So.
They add just the right amount
We've
of
been
chlorine.
drinking bleach ever since we were born.
So.
Reggie, isn't it?
Well, they add fluoride to the water too in a lot of places.
Oh yeah.
Now we heard, what was that? A rumor that fluoride was added accidentally.
And then it was like mandated, isn't that what you said?
It was mandated.
And the government's
I
like,
don't
we
know.
want to do that.
He doesn't subscribe to those conspiracy theories.
That's a good question. I don't know.
Then you add iodine to your salt.
Okay, so how much does water treatment cost? Oh, I didn't plug in the numbers on that one. So water and wastewater treatment are pretty variable. Like the cost is. Oh no, I did fill it in. It just never updated. Oops. So water treatment is generally like $2 to $4 per 1,000 gallons, but that's everything, right? Like you can't say how much does it cost for water treatment, because what do you have? Well, you've got the actual treatment, then you got all the pipes, and you got all the people that run the plant and that work out on the pipes, and you've got the cost of all the chemicals. There's all kinds of things that roll in there. So when you look at a cost for water treatment or wastewater treatment, you're looking at the cost for basically delivering the product. So water is like $2 to $4 per 1,000 gallons. Wastewater's about twice that, about $4 to $10.
But that's just the plant.
No, that's the cost.
Oh, that's everything.
Yeah,
end to
that's
end.
everything, end to end.
All right.
That's like what you pay. Like if you look at your sewer bill, you're going to pay your sewer and your water. You're going to pay $2 to $4 per 1,000 gallons, and you're going to pay $4 to $8 for wastewater.
Any idea how much water I use when I take a shower?
Everybody, per capita, it's about 100 gallons a day per person.
Oh, okay.
So that's like that's like the rule of thumb that everybody uses. But that's everything. That's your laundry. That's flushing the toilet. That's taking a shower. That's washing your hands.
Water.
Yeah, 100 gallons a day.
Okay.
So if you think about that, so if you're using 100 gallons a day, and there's 2 million people, right, in St. Louis. That's 200 million gallons a day of water. So, yeah, we use a lot of water.
Fortunately, it's abundant.
It is
Yeah.
abundant.
We have to
What
clean all of that. That's a
what bodies of water do you use? And I think that your intent of that question was, where does water come from? The Missouri, the Mississippi, smaller like the Merrimack, and then a little bit of groundwater. But for the most part, like I think total, like in the U.S., I think like 70% of the water comes from surface water. I'm not 100% certain what that number is. That's probably something you can look up online. But I think that's about what it is, about 70% surface water.
So because of that, groundwater, hard water isn't necessarily, for most people, it won't be a problem.
Yeah, I mean, you do have some surface water bodies are going to be more hard. Depends on where they are and like how fast the water moves. There's so much involved, right? If a stream moves pretty slow, maybe it picks up more water, or if it's really rocky. The Mississippi's fast and big. The water's not super hard, so. Okay, what are some seasonal difficulties and phenomenon? I mean, there's a whole bunch of stuff that goes into both getting potable water, drinking water, and wastewater treatment. Like, the water changes, right, during the year. The water changes all the time. Like, so the guys that are treating water that they're pulling from the Mississippi, if the water's way low, it has one characteristic. When you get a flood, it changes. So they're always constantly changing how they do their treatment, like every day, basically. They will tweak things in order to account for the different quality of water. In terms of wastewater, the biggest thing for us is in the summer, because for recreation, you want to treat the water more in the summer because people are using things like the Merrimack and the Mississippi and the Missouri. Let's see. How much energy do you use? That's a question that I really couldn't answer. Because it's really hard to say. Like wastewater treatment, a huge water treatment and wastewater treatment, huge part of the cost. Biggest part of the cost is probably energy, because it takes a ton of energy to run pumps and equipment and disinfection, and all this stuff takes a bunch of power. And one of the things that the treatment facilities are always doing, they're always looking for ways to save money on energy. Like, they switch out lights, they switch out equipment to higher efficiency stuff. They look for ways to recycle and recapture and reuse, because it's such a huge part of their expense. They're always looking for that. And they're always negotiating with the power company on getting better rates. So energy is a big issue. One of the things that we do a lot of is energy optimization. So we actually will go into a wastewater facility or a water facility and like look and say, how can you change what you're doing? And some of these places, it'll be like, you change some processes around and you save $500,000 a year. And some of them you look around and you go, you can change this and this and this, and you save $500,000 a month. Yeah. I mean, you're talking about big facilities where they use a ton of energy. So there are ways to really save money, and energy is a big issue. Is water supply a problem? Here, no. California, Las Vegas, Arizona, Wyoming, yes. Yes, like 100 times yes. Water availability is a big issue in a huge part of the world. Here, we just have it easy. So, those were all of your questions. And let me see if the girls asked any that were
super good.
Yeah, they did ask a few really good ones.
You also sent him the girls' questions.
He's going
Oh.
there.
I'm going there tomorrow.
Oh.
Yeah, I think the girls asked better questions than you guys did.
Yeah. Yeah, I would expect that.
Let's see. So they asked, how much water does a typical facility treat per day? So it can vary. Like there's just an enormous variance. So like a little town that has their own treatment plant, they may do 50,000 gallons a day. The biggest treatment plant in the U.S. is in Washington, D.C. They do 1 billion gallons a day.
That's a lot.
Yeah,
Wow.
1 billion. The plant it's enormous.
And this is, it's creating fresh drinking water.
No, this is wastewater.
Okay.
Yeah, and drinking water, the plants are going to be, a little bit smaller because, so the wastewater, like in DC, like everything goes to this one plant because of gravity, right? Wastewater, mostly like you want to put everything at the low point because it all flows downhill. So in DC, just the way that it's organized, that plant covers everything. Water treatment, they'll have a bunch of smaller ones.
So Obama's poop mixed with everybody else's poop?
Yep.
It's all the same?
It's all the same. Water treatment, I don't know what the biggest water treatment facility is. I'm sure there's some that are doing, I think the ones in St. Louis are like 200, 250 top out. I bet there's 250 million gallons a day. And then I think I'm sure there's some water treatment facilities that'll do 500 million, if not more. So, let's see. So they asked what's the process for cleaning, which we can talk about. Do you have to run it through that process multiple times? No, you just do it once.
So for wastewater, they just, it's a multi-step process, but they just do it once?
You do it once, yep.
Okay.
How do you keep fish and reptiles out of the water system? I thought that was a good question. So they have big screens. Like, if you ever drive over the Mississippi and you look out in the middle and you see these like towers, those are actually the intake structures. So there'll be a tower like out in the middle, and that's basically where all the water comes in. They have a giant pump and it pumps the water in. And they have various screens and everything over that to keep fish and reptiles and big stuff out. One of the problems, and we don't have it yet, but one of the problems that they've had in other places, and the Great Lakes had this about 20 years ago, are zebra mussels, invasive species. And the zebra mussels would actually clog the intakes. They would like totally cover the intakes, so they had a bunch of problems, and they figured out mostly how to treat it. They treat them with various chemicals and stuff.
Okay.
But zebra mussels are invasive species, like the Asian carp. You guys have heard about those, right? Those are in the Illinois River. Not sure about the Mississippi, but the big issue, like that everybody's freaked out about, is that they're in the Illinois River, and the Illinois River goes to the Great Lakes.
Yeah, I thought they were already in the Great Lakes.
Yeah, no, I think they're they're like right on the bottom. They have like electric nets up. They do all kinds of stuff because they do not want them in the Great Lakes because they're worried that they're gonna like take over, kill all the salmon and trout and everything else. Bless you.
Bless you.
Okay, let's see.
She's like sitting at your feet. She's like, John, I'm here. What's going on?
Sorry, I'm not scratching you.
How are our buddies?
According to this, the biggest wastewater treatment plant is in Montreal, Canada.
How much does that one do?
It says its dry weather capacity is 2,780,000 meters cubed per day. I'm not sure. All right, that's different.
Yeah, and so one thing too. Oops, what happened? One thing is you actually have dry weather and wet weather capacity. So like a treatment plant, this is for wastewater. So like on a normal day, right, if it doesn't rain, like they may treat, so a good example is there's a plant in St. Louis that we just finished a job on. Their dry weather flow is like 25 MGD, 25 million gallons a day. Wet weather, it's 150. So when it rains, you get all that water in there. And actually that's a problem that communities across the country, especially in this part, like nominally east of the Mississippi, or the Mississippi and east, because of the age of the communities, is we have a lot of wet weather problems. Like when it rains, our systems get inundated, and communities everywhere. St. Louis is doing it, Columbia, Memphis, Omaha, Kansas City, all these communities are doing a bunch to try and get water out of their sewer system because it causes backups and you have to treat it all. So there's a difference between wet and dry weather capacity. and how much they treat. That billion gallons is wet weather capacity. Let's see. What new technologies are coming? That was one that they asked. There's always new technologies coming, but it's usually refining old stuff. Nowadays, there's not like this brand new, holy cow, we have this new way of treating water. It's, hey, we had this method of treating water and we slightly tweak it, we improve it, we make it more efficient, we use different chemicals. So I don't know that there's a ton of like brand new technologies that are totally new. It's more refining. And then let's see, well, what's one of the biggest problems in wastewater treatment is pharmaceuticals.
Somebody mentioned that.
So
people flushing their pills down the
yeah,
toilet.
they flush their pills down the toilet and we don't have any way to treat it
Why do they do that?
because people are dumb.
Why would they?
I didn't know
Where
that
would
was
they
like a
put
thing that was
Why
bad.
are they doing that to their pills? Don't they need those? Why are they putting away their pills?
Well, like you get an expired medicine and people will dump it down the toilet. Like they look at it and they go, oh, this expired in 2016. I only finished half of it. They dump a bunch of antibiotics in the water. And oh, poor Bluebell, nobody's paying attention to you.
That's pretty dumb.
So, yeah, pharmaceuticals is a big deal, and there's no, right now, there's no way to, right? There's no real way to treat it. That's something that's,
Campaign.
so,
What about okay, go ahead.
so one of the other big issues in wastewater treatment is, and you guys probably heard about this, is flushable wipes. Like they call them flushable wipes, you know, like baby wipes, and people throw them in the toilet. Well, those don't degrade.
Yeah, they're not flushable.
Are they the ones that are like kind of papery, like cottony kind of?
Well, they call them flushable, but the problem is they don't degrade like toilet paper does. So when it gets to the plant, it hits the screen and it blinds the screen, and then it causes all kinds of problems.
Oh, no.
So like wipes are bad, and that's something that the industry has been working on in educational campaigns. You know, don't flush wipes. People
Why don't they
still-
tell the companies not to
Yeah, like what the heck?
market them as flushable?
It's like maybe you can.
Well,
step
they
back.
don't
false
like
marketing.
so like a Clorox wipe.
Yeah.
They don't market it as flushable. People still throw it in the toilet.
Oh, it doesn't say flushable wipe on it. People
Right.
just
And
say-
even the ones that are flushable don't degrade quite right. They still have issues.
That's false marketing.
It is false marketing.
Yeah.
That's illegal.
Let's see.
I already-
Oh, they asked, how do you determine when water's clean enough? Water and wastewater get tested basically constantly, all the time. They'll be testing the water 6, 7, 10, 15 times a day. So they're always testing the water, and they have a lab. Like every big wastewater facility will have a lab right there. They'll pull samples, they go and they look in the microscope and they count bacteria and they run tests on it. So they're always looking at the water quality all the time, both for drinking water and for wastewater. And let's see, I think that's probably all the questions that you guys had. So let me, what's your Wi-Fi password?
Green Monkey 59. You're looking for AT&T, DF, and
Yeah,
DNFB or whatever.
DNFI.
Yeah.
What is it?
Green Monkey 59.
Any capitalized or anything?
Nope.
Come on, keyboard. There we go. Green Monkey 59. Join. Okay, so wastewater treatment. Let me pull up a schematic here. Man, Harvey is going to be a big deal. Holy cow.
I know.
So they are talking about getting 40 inches of water, which
Oh, I
is
heard
like,
that.
it is an absolutely
That's a lot of feet.
insane amount of water.
From what?
So let's,
Harvey.
from the hurricane.
Hurricane Harvey.
What's Harvey?
Hurricane Harvey.
That's a pretty silly
Oh,
name
that's
for a
lame.
hurricane.
Yeah.
They're not
Harvey
like giving it a
Davidson.
cool future. It's just like
Why did they
Harvey.
name them? They gave them names for a dumb reason. I can't remember what it
Probably.
was.
Why do
hurricanes have names.
Hurricane
Okay,
Billy.
so let's find one that's actually.
That'd be the name of a
readable.
hurricane, I were to say.
Hurricane Trent.
Storms are given short, distinctive names to avoid confusion and streamline communications.
Nobody understood that.
Hurricane Ike, the third host.
We've really done it this time.
So, how do you protect a water treatment or a wastewater treatment plant during a flood? Aren't they very vulnerable to such a thing?
Yes. Well, yes and no. So, you guys remember, right? We had 2 floods, like in the last 2 years.
Yeah.
So in not in 2017, but not this January, the January before, the plant down in Fenton flooded. It was 100% underwater, like 100% underwater. So what that meant was the plant was dead. It was totally offline, and that plant is low.
That's a wastewater plant.
It's a wastewater plant
Yeah,
because
we're-
all the plants are built right by the water,
Yeah.
and they're built really low. So they all have levees protecting them for the most part.
Okay.
Like that's what they do. They have flood protection.
Uh-huh.
In this case, the Fenton flood protection was not high enough.
Okay.
And
Oh boy.
so this last year, what they did is, I don't know that I may have a picture of it. Last year, what they did was they went and sandbagged all around the
The levee to make it higher?
Is
yes.
that the most efficient way?
In a pinch.
In a pinch, yes. We're actually doing a project for them right now to do a bunch of flood protection, raise a bunch of manholes, raise structures to make it so that it's not going to flood.
That's good.
I don't know that I took a picture then. I think our structural guy was out there and took all the photos. Yeah, I don't have anything.
So it went completely underwater, completely offline. The Fenton plant is not handling wastewater. So who's handling that wastewater?
The river
It just goes straight in.
went straight to the river for about
Oh yeah.
6 months.
What?
Yeah.
Oh.
For 6 months we
Well,
didn't
no, they
treat
had
the
it. No, I'm
water?
sorry, they had it online in April.
So 4 months.
So 4 months,
Oh, wow.
20 million gallons a day, just right out to the river.
so that plant was very, very damaged.
Yeah, it cost them about $8 million to fix.
That's no good.
Whoa.
So, and then it almost flooded again. I mean, they were out there. They had to get there by boat, and they were out there like
Pumping and-
barely keeping it up.
Mm-hmm.
And yeah, so it's a big deal.
So do they turn is the plant still processing wastewater at that time? No, they turn it all off and they just try and keep it
Yeah,
dry.
when it flooded, when Fenton flooded, I mean, they just left. They tried to turn off as much equipment as they could,
Mhm.
like to protect it,
Mhm.
and they just left. But
That was in 2000.
yeah, that was it.
15,
A
16.
year and a half ago
But during the flood
of
this
16,
summer-
17.
Yeah.
Yeah, so the one this year, what they did is they sandbagged all around Fenton
Okay.
with these big giant like 3x3 bags, and they filled them with sand and flowable fill. They filled them with a bunch of material, and then they put plastic around it, and they
Yeah.
basically built a flood wall.
Yeah.
And then they
Pumps behind it.
basically they blocked the entrance to the plant so that water couldn't get in, so that it would back up in other places.
Right.
Because it was inundating the plant. It was threatening to flood from the inside out.
Yeah.
Like it almost flooded inside. So they protected it against that.
And the plant's not running at that time. They just
No, it's running as much as it can.
Oh wow.
Yeah.
So they're not dumping raw sewage into the.
Oh no, they were. They were. So like, let's say that plant can treat. I think that max that plant can realistically treats like 25 mgd. They were getting 50. So they basically just brought out a truck with a bunch of pumps on it, and they pumped from the one side of the levee, and they just pumped it right back into the river. They were just pumping just to keep the water from going into the plant.
Okay.
Yep.
Crazy.
So yeah,
And
when
then other places have to foot the bill when treating that kind of stuff.
So
no,
that's-
nobody treats it.
So that's
Oh.
sewage. No, it just goes right into the river.
It just goes right into the
Well,
river.
yeah, but
So-
when the river goes down, do
Oh,
other
yeah.
places have to deal with that waste?
Yeah, but
It's
again,
diluted,
it's
so they're just
diluted.
Yeah.
So
Okay.
yeah, you wouldn't want to be hanging out right at the downstream of where it's discharged because
This is
it's,
why you don't want to be in floodwater.
Oh yeah, yeah. Don't floodwater's bad.
Yeah.
Yeah, floodwater's really bad.
It's because we can't treat the sewage. Okay, so when you say it's supposed to handle 25 mgd, but it's getting 50, that's because all the runoff and rainwater is combining with the raw sewage.
Yeah.
So you're getting a bunch of water from.
Yep. You get
the
water
streets and
from the
stuff.
roads and down, and again it's you have wet weather, so when it rains, it's called a peaking factor.
Mm-hmm.
So what happens is if you expect 2 mgd during wet weather, you expect 6 mgd. Well, you get a big event, and now you're at 15 mgd. So this is probably a pretty decent of biological treatment. So let's see.
So okay, so you said for. I guess I'll let you look.
No, go ahead.
So you said for water treatment, basically they're just getting the sediment out. They're trying to get the bacteria out. They're trying to make it look nice.
Yeah, for drinking water.
For drinking water, they're getting the bacteria out with chlorine.
And it's got to be drinkable, right? I mean, you're taking out the grit, you're taking
Sure.
out any potential contaminants. But again, usually you're finding a water source that's not really contaminated.
He's actually being nice.
Jack is.
Yeah. Usually you just like pins her down. So you're getting the sediment out. You're getting the bacteria out. You're trying to make it look nice.
Yep.
Putting fluoride.
Yep, putting fluoride. Yep.
Chlorine. Sending it down.
Yep.
But the wastewater treatment is much more elaborate.
Yeah, because it's more complicated. There's more stuff to do. So here's a good schematic for wastewater treatment. So here, come over here and look at this one.
Ooh.
All of you
All
guys.
y'all.
Okay, great.
So I mean, if you want to know like how it generally works, right? So you have, this is for biological, right? So you have your primary treatment, secondary treatment, and tertiary treatment. So primary is, so you start here and you have screens. So you get out all the crud, right? Like all the big stuff. So sticks and gravel and rocks. So you'll have a couple of screens. Like this says coarse screens.
Where do you put it?
What do you mean? This is like at the front of the plant. So it's like
put it?
right when it comes in. Where do you put that stuff?
Mm-hmm.
Landfill.
Okay.
All that stuff, all the grit and sand and everything else gets hauled to a landfill because it's all contaminated. It's all right. It's been in wastewater, so you can't use it for anything.
Right.
So this gets all the coarse and fine screens. All that stuff gets hauled off to a landfill.
And your flushable wipes are in there?
Oh yeah, all the stuff, tampons, condoms, you name it, all that stuff. If you go to a screen at a wastewater plant, it's like that's what you see: condoms, because people flush condoms, and you see wipes and gravel and tampons and basketballs and squirrels.
Squirrels.
Squirrels and tampons.
Yeah, so you get everything at a screen. So then you have primary clarification, right? This is like your primary treatment. So that's where all the...
What's the sand and grit removal? Is that?
This is like a fine...
vortex?
Yeah, there's a bunch of different methods for doing sand and grit removal. Some places don't need to do a bunch of grit removal, like because of the character of their wastewater. They may just have like a fine screen. Other places will have like a big vortex separator. There's grit chambers. There's all kinds of different stuff. Okay, so primary clarification, this is like the main step. This is where all of the, basically of the poo settles out. And clarification is usually a big tank, and the water just slowly moves through, and everything settles to the bottom. All the solids settle to the bottom, they get sucked off. And that's what this is.
Are those pumps down there at the bottom? What is that?
This here is digestion, so let's get to that afterwards.
Okay.
So this here, this part, primary and secondary, this is where there's a whole bunch of different technologies. Like there's a ton of different ways of doing stuff. Digestion is usually like probably one of the big ones. So then you have aeration, that's used to get rid of things like phosphorus and nitrogen and ammonia, and there's a whole bunch of treatments in here, and this is the complex chemistry part that I'm not super good at. This is not my area of expertise. But ultimately, you do aeration, and it helps the bacteria to clean the water. Then you go to secondary clarification, which is, again, you're stripping out all the other stuff, and it goes back into this, and we'll talk about this again later. Then you go to disinfection. So disinfection, there's a whole bunch of ways that they disinfect water. They use chlorine. They use other chemicals like chlorine. They use ultraviolet. Like have you ever seen those hand washers, right, that have the UV light on it?
Yeah.
They'll use these big, giant, huge banks of UV light that's super, super bright, and they just run the water through and it disinfects it with UV. Chemical, doing it with chlorine is probably the biggest way. And then, so then this is tertiary. So then, like, they can do other, sometimes they'll have other nutrient removals. Nutrients are a big deal in wastewater, right? Because think about what you see in fertilizer. It's nitrogen and phosphorus. Those are like the big things, right? So sometimes you'll have nutrient removal. But this is kind of the big process, right? Then here, this is all what you do with, this is all what you do with the stuff that's left over, right? So wastewater, you have a byproduct.
The first byproduct is the sticks which goes to the landfill.
Yep.
And then the next byproduct would be the sand and the grit, and
that's usually all rolled into one. Like they'll usually take all that into the same place.
Okay, so then the next byproduct
is sludge.
Is the sludge.
It's sludge. That's what it's called. Okay. It's called sludge. Biosolids is like a more politically correct.
Biosolids?
Biosolids. Yep.
Okay.
Which is what they are.
Solids or solids?
So solids.
Okay.
Biosolids.
Okay.
That's kind of the terminology, right? But it's sludge. That's what everybody calls it.
Okay.
And that's what it is. It's now when you think of sludge, though, it's not thick. Like it's not like goop that comes out of the wastewater process. It's like 5 to 10% solids. So think about in a gallon of water, like 5% of that is the solids. But that's how it comes out. And then treating that sludge, there's a whole bunch of different ways that they do it. But ultimately, you get the water out, and that water goes back to the plant and gets treated. And then you have like thicker sludge left over, and then they'll do different things to that. Some places will burn it. They incinerate it.
That smells great.
Believe it or not, you burn it hot enough and it doesn't smell. Oh yeah, you probably don't need... Oh, man, that was weird.
Siri, kill yourself.
So, yeah, you probably don't need to tape that anymore. I don't know that there's anything that I'm going to show you here. So, dealing with sludge, though, is a big thing because it's a big byproduct. So, St. Louis, they incinerate a lot of it. They just burn it. And they have a big smokestack, super hot fire.
Isn't the sludge good fertilizer?
Yes, but you have to treat it more to use it as fertilizer because it's got human waste in it. So you have to do more stuff to it in order to treat it to be used as fertilizer. Okay. So they have like different classes of fertilizer and different classes of waste. So you have to do different things. So some places some of them will haul it to a landfill and use it for daily cover. Some will land apply it, like if it's clean enough, they'll land apply it, which is basically they're using it as a farm. Some places will bag it and sell it at like Home Depot as fertilizer. So the sludge is, the biosolids is really kind of like one of the hardest things to deal with because you have to do something with it. Some places now, one of the things that they're trying to do for energy is they actually take that and they burn it and generate energy from it. So
instead of like burning coal?
Well, yeah, instead of burning some natural gas or coal or something else or getting power from the power company, they'll burn the biosolids and then they'll generate energy.
For their own use?
For their own use. And then if you generate more, then you send it back to the power company.
That's clever.
Yeah. So
Save on power because you said power was their biggest cost.
It's a huge cost, yeah. So that's why everybody looks at stuff like that.
So does burning of the solids, does that generate any like pollutants in the air? Or?
Yep, they have air pollution requirements. So St. Louis MSD just went through a big project to fix their incinerators, and they add scrubbers, which are basically like, like an air filter on your furnace or your car or anything like that. It's the air goes through it and it scrubs it and gets all the particles off and everything. Let's see. So let's look at a water treatment schematic, and I can kind of walk you guys through.
So this didn't have the holding ponds, or were the holding ponds that first step where it slowly spins the water?
Those are clarifiers, yeah.
Okay.
Well, holding ponds, I mean, like lagoons
Clarifiers.
and stuff like that. I mean, people still use lagoons for wastewater treatment, which are just lagoons. It's like if you ever, go to a small place and small community and you see there's like the,
A big pond.
a big pond,
Square.
it looks like scum on the top. That's a, that's a lagoon, and they're using that to treat the wastewater.
Okay.
And it's biological, right? You control the rate and everything else, and things settle out, and then you use the biological to clean the water. So let's see. So water treatment. So that one's a little bit more complicated. Let's see. Direct filtration. Let's see this one. No, that's not it. Let's find a good one for water treatment.
She's attacking.
Oh.
Jack's attacking Luca.
Can you stop? Are you guys insane?
Into the gas.
Off they go. They're out of there.
Can't save her.
Wow, Sam. Cringe.
Okay, here's a good one for. Here's a pretty good one for wastewater or for water. So, I'm not sure where this is from,
Okay.
but water's pretty similar, right? So it brings in the water. They have some sort of screening again, right? They want to get out any of the solids. Then they have.
Again, landfill, or that's not contaminated, right?
No, this is. Oh yeah, no, that'll go to a landfill.
Okay.
Yeah, they just haul it to a landfill. So then this is somebody specific. So, but they're going to pump it, right? So one of the things for sure about water, like drinking water, is you have to pump it because you're actually taking it from the low spot to the high spot. Wastewater, you still have to pump it, but you're taking it from the high spot to the low spot. So you always have a lot of pumps at a water treatment. So then this, they show some pre-chlorination. This here is essentially the biggest process, right? So this is coagulation, flocculation. This is where you get all the stuff out. And it goes through a series of, a lot of times you'll see it and it'll look like a little maze where the water will just kind of meander through because they want to slow it down. They want to make it go really slow and all the solids settle out, and then they pull the solids off the bottom.
How do they get it up? How do they get it out?
They suck it out with a, with a pipe. Yep. So, and again, that'll all, all that stuff gets pulled out. Then they'll have like a sedimentation basin, which again is more stuff to settle out. The biggest part of water treatment is getting stuff to settle out. Then this is kind of where they show filtration. So if you guys ever used like one of those Brita water filters, right? Like if you ever seen a water filter like at a house.
Yeah, I've seen them at other people's houses.
Yeah, so that's basically what this is. The water will slowly go through various layers of stuff. So this could be, what does that say? Anthracite. So it'd be like carbon. It'll be some sort of something that helps take out any of the contaminants. Sand and gravel, and what happens is all that stuff sticks to it, right? And then what comes out is eventually clean water.
Don't they have to change their filter?
Yep.
How often?
Not sure.
Yeah.
I'm not sure. But yes, they will have to, and they back flush it too, right? So you can back flush that stuff and push out, wash a lot of the junk out. So then here's more chlorination, and then they go to, a lot of places will have like more basins, and they just call them clearing wells or clearing basins that just let the water sit, slowly move through, more stuff settles out. And then now here's you're going right and you're pumping everything, and then it'll go to water towers, or it'll go to big basins, and then it eventually, goes to a reservoir, and then it'll go to your house.
Well, okay
So,
then.
so the big part of water treatment is this right here, which is slowing the water down, settling it, adding some chemicals, running it through filtration. There's a bunch of different, like I said, there's a bunch of different ways that they do all this, but this is kind of a general thought and a general schematic. So,
So where do the improvements come there? Like we could replace these pumps with higher
yeah.
functioning, more efficient
Diff-
pumps.
different chemicals, like more efficient use of chemicals. A big part of, like, a big part of their cost is pumping and chemicals, right? Because most of it is, there's not a lot of biological process for water treatment. You're just slowing the water down, letting it settle out, running it through various filters. So most of the cost is in chemicals and pumping. And so that's what they're looking at. On the wastewater side, a big part of the cost is aeration. And I showed you guys where they have aeration. They have basically what they are is big fans. And they blow air into the water.
Specific chemicals in the air, or just
No,
air?
it's just air.
Just air, and
Yep.
that helps the.
Biological process work, yeah.
Okay.
Yep.
So thirsty.
Yeah. He did that earlier
He's been,
too.
yeah, he's been doing it for a while. It's my cup.
Dude, you're going to get your head stuck in there. Bluebell's going to laugh at you.
Yeah.
So are we.
So Phil was like, "You dummy, the glass is too little. Drink out of the toilet like me."
Okay, so what else do you guys want to know?
All right, so we that's a bunch of different stuff. I don't know. What did you hear that is interesting that we should research more? What did you hear that is something that you felt like you could innovate on or improve on?
Oh, I
There's
like
so many different ones.
Exactly.
I liked
So much.
hearing about how you said that in Flint, Michigan, how whenever the only reason the whole lead thing happened because they didn't purify it correctly.
Or put the
They
right
didn't add the
anti-
right anti-corrosive chemical, yeah.
So like one small thing could end up costing.
Bunch of, yeah. And lead is bad.
Very.
Oh,
Okay,
Oh
okay.
no.
no donuts for you. Sorry, buddy.
Send them outside.
Yeah, he's probably just
Um,
annoying us because he wants outdoors. I don't know how you're not getting roasted right now.
I know he's like chill right now.
He's chill. What are you talking about?
I know, but like sometimes he's like extremely unchill, and other times
Like
he
goes
just,
crazy.
He might as well be-
99% of the time he's pretty chill.
Well, Bluebell be chill.
She'll be chill now that he's gone. She doesn't like to be picked up.
I know.
it doesn't matter. You do it anyways.
Okay, so the Flint, Michigan thing was interesting to you, and how they just didn't add the right anti-corrosive. So the new water from the river started corroding the pipes, and those pipes, then the water started leaching into the water. The lead started leaching into the water. Very much beautiful.
Yeah, lead's a big deal.
Outside or something?
She doesn't go outside.
Bo is not allowed to ever go outside.
It's a bad situation.
So oddly enough, a lot of interesting ideas on our team come up
Yeah.
on accident
Mouse
as
traps.
jokes.
Yeah, catapult mousetrap. Next thing we know, we built a little slidey thing. It was practically a miniature catapult.
And our jokes come into actual projects.
Yeah. So last meeting, I had come up with a water treatment plant that, like you said, was kind of like a closed to cycle kind of thing.
Mm-hmm.
But you could potentially use the wastewater or other sources of water to go into a sort of another, like, say, nuclear power plant.
Mm-hmm.
Would that require any more sort of treating of your knowledge?
Not sure. My guess is, like water that goes to like a nuclear power plant, they may pre-treat it.
Yeah.
I'm not certain, but my guess is they would probably pre-treat that water because it needs to be it needs to have specific characteristics. Like some industries will pre-treat their water. Trying to think of a good example. Well, like a circuit factory, like some place that makes circuit boards and stuff like that, they use a stupid amount of water. They probably pre-treat their water because they're using it for cooling and everything else, and they may want like no particulates and stuff like that. So they may even treat it, more. Not sure.
So we learned from another guy that when water goes into a factory, sometimes they have to treat it before it comes in.
Mm-hmm.
And then when they send it back out again, they might have to pay more if they don't treat it before they send
Yes.
it back to the
Yeah,
back to the city.
most places that treat wastewater, like MSD or big, they have what's called an IPP program, industrial pretreatment program, and that's basically exactly what it sounds like. Like when Nestle, they're going to pre-treat all their water, and they have people that work with all the industries that are big water users and big water dischargers to make sure that the water that they're getting is okay. And they may require some people like a rendering facility. You guys know what rendering is? Rendering is like where they chop up.
Oh, meat.
Yeah,
Oh.
where they chop stuff up. Those plants have all kinds of issues, and they have to do a bunch of pretreatment because the water coming out of those places is challenging.
All right. So when they before they send their water into the sewage system, they need to treat it.
Yep.
Okay.
Yep.
So we were talking about a desalinator,
Mm-hmm.
and there's they use the heat. The most common way to desalinate, I guess, was with steam by heating the water into steam and then collecting it off.
RO is what they reverse osmosis.
Oh, that's the most common.
Yeah, I think so.
Maybe it was the
What is
simplest
that
with
do?
steam.
Well, and I mean, no, that's a good question. I mean, I know the plants that they're building now, like the big plants, the ones that because they just did one, like a big giant one in California, and they just did a big one in Texas not too long ago. I think those are all RO plants, reverse osmosis. Desalination works. It's just super expensive,
Yeah.
super energy intensive. And
So if you can find a way to desalinate cheaply,
yeah, and there's a whole bunch of smart people that are working on that all the time because that's like a big deal. Because like California, for example, if they could cheaply desalinate, that would probably solve most of their water issues. Yeah.
just have to pump it from the coast. All right, and then we were talking about nuclear power and desalinating, right? But we have a nuclear guy we can talk to. Did you talk to your uncle?
My parents, they're just, stuff's happening, so they're gonna get to that as soon as they can.
Okay. All right. What else you got?
You guys don't know your mission yet, right? They haven't announced what.
The project is?
Yeah.
No, but I think we've puzzled it out, right? Well, we know what they typically.
Hopefully.
We know what they typically are.
Okay.
Anyway,
Well,
this
'cause-
is raw information as well. It's going to be useful for a lot of different things.
Sure.
So some other things to think about, right? So you've got, well, we've only talked about water and wastewater. There's also another big, super big component of water. You guys have any idea what it is?
Mom would say gray water.
I would say temperature.
Well, a big type of water that we have to deal
Gas?
with. Stormwater. When it rains, where does all the water go?
I once saw a storm, one of those storm
Everywhere.
things, and it was just spewing water up. It was like a fire hydrant that got torn off.
Yep.
So I thought the storm water went straight into the sewage plants as well.
No.
Stormwater
Oh,
just
well,
goes
okay.
everywhere.
Okay,
Totally
so-
misunderstood then.
So
Why does the water into the sewage plants double during a storm?
because the pipes are old and they aren't
Watertight?
They aren't watertight.
Oh, okay.
And you get manholes, that water gets in there, and
Okay.
so hold on, let me do this. So there's there's different types of sewer systems, right? So you have a sanitary system, right? So you have a sanitary is, you have one pipe, and that goes to the plant. and then all your houses, right, are connected. So like you have, this is sanitary. So you have a sanitary sewer, right? This only takes in houses, right? And industrial and everything else. And next to that, you'll have a storm sewer. And this goes to the river. And this is a storm. And the only thing this picks up is surface water. So it picks up runoff. This is a separated, called a separated system. This is what most of like St. Louis is. Most of St. Louis is separated. The problem with stormwater is most of it goes into the storm sewer, but the sanitary is old and leaky, and what happens is stormwater will come in like here, and it comes in through the leads, and it finds its way into this. That's why when I talk about the peaking factor, sanitary, if you treat 5 million gallons a day, when it rains you treat 15. Some places treat 5 to 50. That's a real problem. This is something that communities are spending millions and millions and millions of dollars to fix. Because when you get too much water, what happens is when you get to the plant, the water can't go to the plant. It'll inundate the plant. And then you have what's called an SSO, which is a sanitary sewer overflow. Those are bad. Because that's like direct sanitary going right.
No, you had me at sewer overflow. I got the
Okay.
visual.
So, yeah, that's bad. So, but then you have a storm sewer, and the storm sewer, the storm sewer system may be pipes, but it may be, it may be a creek, right, that comes in. I mean, you can have a bunch of different things going on. This is all part of the collection system. The other thing that you have is a combined sewer, right? And a combined sewer is what you have in St. Louis.
What are the circles you draw?
These are manholes.
Oh, okay.
This is like just a point.
Okay.
So a combined system has all of your laterals and all the houses and businesses, everybody's connected. But it also has all the stormwater. So all the catch basins, right, things in the road, stuff like that. A combined picks up everything. Old cities have combined systems. So if you think about it, when I said like east of the Mississippi, pretty much like St. Louis, Kansas City, Omaha are kind of like the westernmost. Everything else to the east, there's tons of combined sewers. These are a problem because when it rains, they pick up everything. So not all the stormwater goes to the treatment plant. Most places, the stormwater goes right to the river. But stormwater picks up a bunch of other contaminants. Stormwater picks up grease off the road, and it picks up grit, and it picks up oil, and that all goes to the river, and that actually has a negative impact on water quality. The other part of stormwater and runoff that's more of a problem, but they don't make it a big problem, is farms. Because what happens is farms put down tons and tons and tons of fertilizer, and their ground is relatively impervious, which means pervious, water will go through, impervious, water runs off. Like concrete is impervious, sand is pervious. A lot of the cornfields and fields are generally impervious because it's pretty tightly packed soil. When it rains, all that crap runs off into the river, and it's got all these nutrients in it because it's picking up all the fertilizer. And that's a real problem, and that's called non-point source pollution. Like it's a non-point source. Like a point source is a pipe. A non-point source is all this farmland runoff, which is a real problem because that actually contaminates the river as much, if not more, than like a wastewater discharge from a wastewater plant. So I don't know what your mission, what the project. If the project is strictly water or wastewater treatment.
No.
But if it's talking about water issues, like
it'll be something like. When you take a guess at what it
Improve the relationship that we have with water as a society and treat water better or whatever.
Yeah,
like water
improve
rights
the
matter.
way that humans use exactly.
okay,
Improve the way that we use water or innovate on a way that we use water
Got it. Okay.
more efficiently.
So it'll be
more
like super broad.
general.
Okay. So
Super general.
So you should also be thinking and considering like what to do with surface water, which is stormwater runoff into the rivers, water pollution, because there's a lot of stuff going on with that. And I mean, we have a ton of problems in the water industry, but that one's just as big as any of the others.
So I have a specific question. So about when you talk about how the sewer system, the sanitary system, is
Yep.
not watertight.
Yep.
So you may have like there may be hundreds of places where water is sneaking into
Yes.
the sanitary system and flowing
Yep.
in. But how are you able to identify which ones are the biggest hitters? Like
Right.
which ones are causing the most problems? Like you may have 100 leaks, but 2 of those leaks may be responsible for 70% of the water.
Yes.
How
So-
do you locate those?
Yep. So what that water is called I&I. It's called inflow and infiltration. So in a sanitary system, which is only, right, sanitary, it's only supposed to have sanitary stuff coming from the house. But it doesn't, because we know that it picks up other water. So there's 2 parts of that water, inflow and infiltration. Inflow is somebody's roof drains that are connected to the sanitary sewer, or a catch basin, like a storm structure in somebody's backyard that's connected to the sanitary. That's inflow. Infiltration is the stuff that Mike's talking about, where you get water leaking in through joints. So to find all that, we do a bunch of different things. They do flow monitoring. So in a big sewer network, tons of miles and miles of sewers and manholes, we'll put monitors out to understand where the water's coming from. So it'll measure the flow. And then we'll go in, we'll TV sewers. So we'll actually run a camera down a sewer, and they look at the pipe, and you can see where big cracks or holes, you can tell where the water's coming in.
Or roots.
Roots, yep. And so we'll look at those, and then we'll determine, based on looking at that, what the worst problem is, and then that's what gets fixed. And Community St. Louis is doing that a ton. Like they're doing a ton of I&I removal. And it's also there's also what we call public and private I&I. So public is the stuff in the road, right? It's the sewers out in the street. Private I&I is from where it leaves the house until it gets out in the road. And you get a bunch of water coming in there because people's leads are old. They're built under trees, and they weren't built to the same level of quality a lot of times because it's a contractor, 30 years ago, just would slap some pipe in the ground. So we have a lot of water coming in from those too. So that is a pretty big issue. It's something that we're dealing with in the Midwest a ton. I would say that we actually have a pretty good handle on it, like we know how to fix it. The biggest problem is money. There's not enough funding for water issues, and there's a bunch of reasons for that. The government's not spending enough money, and places like the city and St. Louis MSD and the water company, they can only charge so much money, right, before people can't afford it.
I think there's laws about how much you can municipal.
They have
state, and federal laws
affordability.
about how much you can charge for water.
Yeah. So water is generally like a regulated utility. Like you have to, for them to raise their rates, they have to go to a commission usually, and they have to prove, hey, this is how much it costs us. Sewage is not. They do their own rate study, and they go, like MSD does a rate study every year or 2 years, and they go, this is how much it cost us, and this is how much we had to pay, and so this is our rate.
That's what we're going to charge you.
Yep.
Okay.